Good morning to all. In previous class, we have discussed about selection of solvents. So, selection of solvents are of four types. Okay. So, already we have discussed one type of reactions, that is nothing but aqueous phase reactions. Okay. So, let's see. So, what is the selection of solvent? Here, four types of selection of solvent. Okay. So, first one is aqueous phase reactions. So already we have discussed about this one, is it or not? Okay. Aqueous phase reactions, and second one is reactions in liquid reactions in ionic liquids, Okay. And third one is solid support synthesis, solid supported, solid support synthesis, whatever it may be. Okay. Synthesis, and fourth one is solvent free synthesis. Means without using any solvent, we have to synthesize the compound. Okay. Solvent free synthesis. Solvent free synthesis. Okay, ma'am. So here, so we have already discussed about aqueous phase reactions. Means we have to take the water as a solvent. So that is called as aqueous reactions. Okay. Aqueous reactions. So in that, so famous example is nothing but Diels-Alder reaction. So in Diels-Alder reaction, just we are taking water as a solvent. Okay, here we are not using any chemical solvents. Okay, just we are using water. So that's why it is called as aqueous phase reactions. Aqueous means water. Okay, we have to take the water. So that's why it is called as aqueous reactions. And the example for this one, aqueous phase reactions is nothing but these are the reactions. So I have already explained you. Okay, I have already explained you. So next one is reactions in liquid. Second one. Let's see the second type. Let's see the second type, which is a reactions in ionic liquids. Ionic liquids. Ionic liquids. So ionic liquids are made up of two ions which are cation and anion. Is it or not? So we have to take the, so here these ionic liquids are made up of the two components, that is nothing but, means we have to combine the anion and cation. Okay, cation. So thereby, so we have to use this ionic liquids in the form of ionic liquids. Okay, ionic means here it is having both cation and anion. Okay, in liquid form. Okay, so ionic liquids, we have to do it made up of these components. Okay, so these are also called as ionic liquids. Can also be called as non-aqueous polar solvents. Means here we are not using any water. Okay, water. So that's why we are. It is also called as non-aqueous polar solvents. Okay, non-aqueous polar solvents. Okay, non-aqueous polar solvents. So this is also called as non-aqueous polar solvents. Okay, so let's see the examples for this one. Okay, so for example, 1-butyl, 3-methyl, 1-imidazolium, aluminate. So this is the example. Okay, aluminate. What it is called? 1 butyl, 3 methyl, 1 imidazolium aluminate. Okay, let's see what is the structure of this one. So here three generations of Indonesian salts are there. So let's see one by one. Okay, so here we are using these ionic liquids. Okay, so they have developed three types. They have developed this non-ionic liquids. Okay, so let's see the first generation of this one. Okay, first generation. So what is Indonesium? Imidazolium. Imidazolium means so imidazole group means it is having two nitrogen atoms. Okay, nitrogen here, nitrogen here. Means here this is having nitrogens. Okay, here N-methyl group is there for this one. Here it is having this one. Okay, and AlCl4 minus ion. Here it is having plus charge. This is developed in 1980 and it is called as first generation ionic liquid. First generation ionic liquid, it is developed in 1980. So here this is called as chloroaluminate liquids, ionic liquid. Chloroaluminate, ionic liquids. Ionic liquids. Let's see the second generation. Okay, so this is the first generation of the ionic liquid, which is nothing but chloroaluminate ionic liquids. Okay, here we are taking the chloroaluminate also this ionic liquids contains the imidazolium group only. Just we are varying anion. Okay, so this is the cation. So this is the anion. Okay, so means this ionic liquid contains cation as well as anion. Okay, so by varying this anion, there are three types of generation. Okay, so there is so means it remains the same, but what is here we are using different anions. Okay, we are using different anions and produces them. So if you use different anions, it will give the generation of means here first generation is, so they are using aluminium chloroaluminate. Chloroaluminate is an anion. Yeah, so first they have prepared this ionic liquid in 1980 and it is said to be first generation of catalyst. Okay, first generation catalyst. Let's see the second generation. Okay, second generation catalyst. So same cation will be there, just we are varying the anion only. Okay, anion. Okay, later they developed. So by taking this cation only, okay, taking this cation, same cation, okay, Bf4 minus means this is a tetrafluoroborate ion. Okay. Okay. This is the tetrafluoroborate ion. Okay. This is developed in 1990. Okay. 1990. So this is stable to air and moisture. Okay, stable ionic liquid. Okay, so this is the air and moisture stable one. Air and moisture stable. Moisture stable means it cannot react with this air and moisture. If it is having any water, so it cannot react with this one, and if you put this in air, so also it will be stable ionic liquid. Okay, stable ionic liquids. Okay, so this is the second generation the ionic liquid. Let's see the third generation. Okay, third generation. So I want to write a smaller because I have no space here. Same cation, we are taking same cation, but we are varying only anions. If you see here, this is the what is the anion used in the first generation. This is nothing but chloroaluminate ionic liquid. Okay. So next, what about this second generation? So in second generation, so they have used tetrachloroborate anion in this one. So this is said to be second generation ionic liquid, and it is more stable. Okay, more stable to air and moisture. Okay, air and moisture. Let's see the third generation. Third generation catalyst. Okay, here they have changed this a branch also. Okay, yes, ethyl group is there. Means here they are using this thioethyl group. Okay, thioethyl group. Here we are using hexafluorophosphate ion. Okay, hexafluoro PF6 minus is the anion. Okay, PF6. This is PF6 minus. So don't write. So this is we have to write. This is a plus anion. Here PF6 minus. PF6 minus will be there. Okay. So this is developed in 2000. 2000. Okay. 2000. Next, this is a task specific ion liquid. It is very specific. It will give the specific product. Okay, it will give the specific product. So this is said to be task specific ionic liquid. Ionic liquid. Okay, specific ionic liquid. So these are the four generation of ionic liquids. Okay, so in that we have seen already aqueous phase reactions. In aqueous phase reactions, so what we are using there, so water as a solvent, but here we are using non-aqueous liquids. Here we are not using any water and all. So these are exist in themselves in ionic form. Okay, means liquid form. This here it contains cations and anions. Okay, so here there are three types of reaction generations are there. So imidazolium cation and will be remain same. Just next, what here in first generation, aluminum tetrachloride is the anion, and in second one, so tetrachloroborate, next borate, next tetrachlorophosphorus. Okay, hexafluorophosphorus ion, PF6 minus ion we are using in the third generation. We are using in the third generation, and it is task specific ion liquid. Task specific ionic liquid. Okay. If you complete, I'll go for next one example. So in Friedel-Crafts reaction, in presence of ionic liquids, we are Friedel-Crafts reaction, we are using these ionic liquids. Let's see the example for this one. Okay. If you complete, I'll go for that. Or otherwise, take the screenshot. This is PF6 mark. This is 6. I think it is not visible. 6. PF6. PF6 minus this one. Okay. Okay. Come on. So let's see the example. Friedel-Crafts reaction in presence of ionic liquid solvent. Friedel-Crafts reaction in presence of ionic liquids. Okay, so this is the example. Let's see the reaction. Means we have to do the Friedel-Crafts alternation, acylation reactions are there now. So we have to take the aromatic compound by using acyl chloride or methyl chloride. So just we are adding alkyl group or acyl group. Okay. So here we have to take this one. So just I have told you we can write it as a short form. Okay, short form in mind. We can write this a short form. AlCl3. Okay. So next, room temperature at 1 hour we got. So here what we are doing, we have to eliminate this H and Cl. So thereby we have to add this acyl group at this position. Okay, at this position by using this ionic liquids. Okay, ionic liquids. So here it will give the 90% yield. 90% yield. So what is ionic liquid we are using? 1-methyl 3-ethyl imidazonium chloroaluminate. What is this here? We are using 1-methyl 3-ethyl imidazonium chloroaluminate. Okay, aluminum chloro. We are using this one. Okay, this one is a this ionic liquid. Okay. So next one, solid support synthesis. Here we are using a solid support synthesis which is a resin beads. Okay. Third one. Solid support synthesis. Solid support synthesis. Okay. Solid support synthesis. Here we are using solid support. So solid support is nothing but a beads, resin beads. We have to use the resins. Resin beads are used as a solid support synthesis. Solid support synthesis. Okay. So these are having some linker. Okay. This is the resin. Okay, which contain this is the act as a solid support and which is linked to the linker. Okay, linker is having some functional groups. Okay, some functional groups. When you add this amino acids or any other one, so what it will do? It will remove this one. Suppose if you take uh, glycine, okay, CH is there, CO, OH group is there. Next, NH2 is there. So what it will do? It will remove the this one and it will give the so here NH is there and which is a CO, C. This is for this. Next H NH2. Okay. So next we have to. This is a resin bead and if you use appropriate reagent, it will go out and it will give the product. Like this, we have to synthesize the desired product by using this resin beads. Next, this is the amino acid one we are using. Next, if you use amino acid two, so next what it will be do? So it will add the we are adding AA1 and AA2. Next means for this NH2 we have to prepare AA2 means it contains again COH group. Is it or not? So so next what will be happen? So it will remove the means this H and that COH group is there now. So we have to remove and that one and forms the another peptide bond. So this CO and H bond is called as peptide bond. So like that we have to prepare the proteins, amino acids or proteins. Okay. So next. Just wait, ma. Just note down that. So here it will so we'll get the desired product. Okay. So this is the solid support synthesis. Okay. Let's see the fourth reaction. This is the solid support synthesis. Okay. Resin beads are used as a solid supports. So next, solvent less synthesis or reactions or solvent free synthesis. Okay. Fourth one, solvent free synthesis. Synthesis or is called as solventless synthesis reactions. Solvent less synthesis or synthesis reactions. Okay. Okay, we can call it as synthesis or reactions. Okay. So here carrying out the reaction between two solid reactions means here we are not using any solvents. Just we have to take the two solids. So what it is carrying out the reaction between two solid reactants, two solid reactants, two solid reactants. Okay, by heating the mixture, by heating the mixture, or by mixing and grinding, means we have to mix and grind this one. Okay, we have to mixing and grinding with the help of mortar and pestle. With the help of mortar and pestle is called as solvent free synthesis. Solvent free synthesis. Solvent free synthesis. Okay. We are not using any solvents here. Just we are taking the two what is that, solids only. Reagent and reactant both are solvents only. Means solids. We are taking solids and just we have to mix and grind in the mortar and pestle. Thereby we have to kept for the heating. Okay, heating. Okay, so here we are not using any type of solvents, just we are using solids only. Okay, solids only, and we have to mix these two reactants and we have to kept in the synthesis, means heating. Okay, heat చేయాలి. జస్ట్ మీరు మీ ఫస్ట్ సెమిస్టర్ లో ఆర్గానిక్ లో చేసింటారమ్మా రియాక్షన్. This type of reaction is done in your first semester organic practicals. మరి మీకు గుర్తుందో లేదా, ఆర్గానిక్ ప్రాక్టికల్ లో ఇట్లాంటి టైప్ ఉంది సాల్వెంట్. we are not using any solvent. What is that, anthracene? We are using the anthracene and one of the solid only. Just we have to grind and mix and we have to keep for the boiling. That means what is that, heating. That's it. Okay, మీ ఫస్ట్ సెమిస్టర్ లో ఉంది మీకు ఆ రియాక్షన్. Adduct, we have to prepare the anthracene adduct by using this method. Okay, solvent free synthesis. Okay, I hope you understand. Now let's see the example for this one. Okay, we have to take the benzophenone we have to reduce the benzhydrol by using sodium borohydride. Okay, so we have to take the benzophenone. So this is the benzophenone. Means here benzene, two benzene groups are there. So one is said to be phenone, which is attached to this benzene. So that's why it is called as benzophenone. Benzophenone. Benzophenone on reaction with sodium borohydride is a solid, not a liquid. Okay, sodium borohydride, which is a solid only. Solid. This is not a liquid. This is a solid. Okay, we have to mix this benzophenone and sodium borohydride, which are two solids. Next, by heating. By heating. Heating. This OH means this is a reducing agent. What it is? This is a reducing agent. Means it adds the hydrogen. Okay. మీకు ఫస్ట్ పేపర్లో వస్తుందమ్మా సోడియం బోరోహైడ్రేట్ మరి మీకు స్టార్ట్ అయిందో లేదో నాకు తెలియదు. ఓకే, సింథటిక్ రియేజెంట్స్ 1లో మీకు ఇవన్నీ వస్తాయి. సింథటిక్ రియేజెంట్స్ 2లో ఏమొస్తాయి? సోడియం బోరోహైడ్రైడ్ is a reducing agent. Okay, so sodium borohydride act as a reducing agent. Okay, means it adds the hydrogens to this carbonyl group. Okay, so it is what it will do. So it reduces carbonyl group into OH. Okay, OH, benzhydrol, called as benzhydrol. Benzhydrol. Here we are not using any solvents. Just we are using two solids which combined means we have to mix these two solids and we have to heat these two solids. Okay, then what will be there? So this sodium borohydride is act as a reducing agent which reduces this carbonyl group into OH group. Okay, OH group, secondary alcohol, means it adds the hydrogens to oxygen and as well as this carbon. Okay, so that's why what it is called as benzhydrol. Okay, benzhydrol means this ketone is converted into OH group. Means what we have to do the reduction means we have to add the hydrogens to this ketonic group and it is converted into OH group. Okay, OH group. So this is the example for the solvent free synthesis. Okay, next, so we have to use the one table for all this. We have to compare which one is usable and which one is not undesirable. Okay, let's see the one table is there. Okay, so here we are not using any solvents, just this is a solid and this is solid. We have to grind and mix with the help of mortar and pestle. Okay, so next we have to transfer it into ground bottom flask and for heating. Okay, So for heating, so then what will be there after some time? So this means ketonic group is converted into OH group. Means here they are adding hydrogens. Means reduction. That is called as reduction. Okay. So next we have to compare all this. One table is there. We have to preferred. Somewhat we can usable, but these are the undesirable. Means we have to avoid this one. But we can use some solvents which are not that much harmful. So this is the preferred. So there are three types of there. Okay. So we have to prefer some solvents. These are preferred and usable. Okay, we can use. So undesirable means we have to avoid all this. Okay, let's see. Water. We can use toluene. So here water, isopropyl alcohol, isopropyl alcohol, isopropyl alcohol, acetone, ionic lipids, supercritical CO2, supercritical CO2. So these are preferred for the synthesis, green synthesis. And there are another type are there. So you can use the toluene, okay, isopropyl alcohol, okay, isopropyl alcohol and heptane, dimethyl sulfoxide means DMSO, sulfoxide. We can use sulfoxide, tetrahydrofuran, this is hydrofuran. Next, acetonitrile. Okay, so next one, dimethyl means we have to avoid all these. Means these are said to be undesirable one, which are dimethyl formamide, DMF, dimethyl formamide, okay, formamide, which is called as short form DMF. Here this is a DMSO, okay, dimethyl sulfoxide is called as DMSO, okay. Next in dioxane and N-methyl pyridinone, N-methyl. So these are undesirable solvents. Means we have to better to avoid all these solvents. Okay. So here we can use. Okay, if these are not that this much harmful, but these are not harmful, we can use. Okay, at any time. Okay. Next, dimethyl acetamide. Dimethyl acetamide. Hexane chloroform. Okay, this is hexane and chloroform. So better to avoid all this. This is exam 1, E. Okay? Exam. Means these are, we can use without any doubt, but these are okay, somewhat not harmful. So that's why these are the said to be usable one, and we better to avoid this one. Okay, we have to better avoid these solvents. Okay, these solvents. So next one, design for energy efficiency. Okay, sixth one. So this is the solvents. Okay, how to which type of solvents we have to use for the green synthesis. Okay, let's see the. Let's see the design for energy efficiency. Sixth one, sixth principle, design for energy efficiency. Energy efficiency. Here we have to use energy requirements for chemical process. What are the energy requirements? Process should be recognized for environmental and economic impacts and should be minimized. Means we have to use maximum, means we have to use the less energy. Okay. So energy requirements of chemical processes should be chemical processes process should be recognized for their environmental, okay, and economic, means less cost, low cost. Economic means don't use the much costlier equipments. So we have to use the, it should be economic. Okay, economic impacts and should be minimized. Should be minimized. So this is the first one. If it is possible, we have to carry out these reactions at the normal temperature and pressure. Okay, if possible, synthetic methods should be conducted at normal temperature and pressure. At normal temperature and pressure. Okay. ఊరికే సింపుల్గా విని ఊరికే ఇట్లా ఉండదు, దాన్ని రాసుకోండి, ఏదో ఒకటి వస్తుంది మీకు. ఓకే, ఊరికే వింటుంటే ఏం రాదు, మర్చిపోతుంది. ఓకే, నెక్స్ట్ కెమికల్ సింథసిస్, థర్డ్ వన్. Chemical synthesis should be designed. Chemical synthesis should be designed to minimize the use of energy. Minimize the use of energy. So these are three important. Means here these should be environmental and economic free. Okay, so next impact should be minimized. If possible, we have to use the synthetic methods at normal temperature and pressure. And what is the third one? Chemical synthesis should be should designed to minimize the use of energy. Okay, we have to use the very smaller energies for the synthesis of products. Okay, so this is this one. So here different energy sources are there in green chemistry. Let's see what are those. Okay, so these are the three important points we have to remember for the design for energy efficiency. Okay, energy efficiency. Let's see different energy sources in green chemistry. Different energy sources in green chemistry. Okay, green chemistry. So here there are conventional heating. Means conventional heating. Here three types of energy sources are there. Bunsen burner, okay, oil bath, and heating mantle. Okay, so these are the said to be conventional heating, and these are the energy sources. Okay, energy sources. And alternative energy sources are there. Alternative energy sources. Alternative energy source for this: microwave, okay, the ultrasound, C, heating mantle. Okay, so this only. And C is sunlight or UV. Okay, so these are the alternative energy sources. Means we can use this, but we can use better to use this microwave, ultrasound, and sunlight. These are the, so here in this process we are using very smaller energies. Okay, so it requires more energies. Okay, so this is said to be conventional heating. So here we have to use as a heat as an energy source. Okay, heat is a energy source, but here we are using this alternative energy source: microwave, ultrasound, and sunlight or UV. Okay, sunlight or UV. Here what it will do here. Okay, just these are the conventional heating methods are there, and alternative energy sources are there. Let's see the difference between what is conventional heating and alternative energy source. Here, what will be there? Energy is consumed. In this three process is energy is consumed. Okay, energy is consumed here. Okay, so here organic synthesis for energy efficiency. So this one means these are will give the faster reactions, faster. Okay, faster and less energy consumed. Less here high energy consumed. High energy is consumed. Next here, less energy is consumed. Less energy is consumed. Okay. That is the difference between these two methods. These two methods. What are the two differences here? Conventional heating is there. Alternative energy sources are there. Okay. So in this conventional heating, we are using Bunsen burner, oil bath heating method. Here, more energy is consumed. Okay. Here, what it is there? Here, more energy is consumed in this by using Bunsen burner, oil bath and heating method. In these alternative energy sources, which are microwave, ultrasound, sunlight. So this will give, and these are the slow reactions. These are something said to be slow method, okay, slow. But in this, if you use microwave, ultraviolet, ultrasound, and sunlight or UV, so what it will give? These reactions are faster. Means within seconds, fraction of seconds, we'll get the product. Okay, so it means these are very faster methods, and less energy is consumed by using these energy sources. By using these energy sources. Okay, energy sources. So that is the use for this the difference between conventional heating and this energy. Okay. So we can see lot of photochemical reactions. These are nothing but it will give the lot of photochemical reactions. Photochemical reactions. Photochemical reactions. Okay. Photochemical reactions. So these are the some energy efficiency, energy sources. Okay. Energy sources. This is somewhat big topic among all the principles. Okay. So I want to continue tomorrow because so we have to explain these methods, what is microwave methods, ultrasound methods, and sunlight methods. Maybe for carbohydrates, I may take class in the evening, okay, or by tomorrow, okay. I will so tell you the timing of the next class, okay. So the next class will be today or by tomorrow, okay. By tomorrow. So we will have continuous classes. Okay, continuous classes. So here I want to stop the class. Okay, thank you to all.